24 billion kilometers from Earth, a spacecraft launched before most of its own engineers were born suddenly stopped making sense. It was still alive. Its radio signal kept arriving steady and clear, but the message inside that signal had turned into meaningless noise. For 5 months, NASA's most experienced spacecraft engineers stared at a wall of numbers that meant nothing. The same broken pattern of ones and zeros over and over, like a phone stuck on a dial tone. Somewhere in interstellar space, humanity's most distant machine was trying to talk to us, and we could not understand a single word. This is Voyager 1, the farthest human-made object in the universe. Launched in 1977, it flew past Jupiter and Saturn within its first few years, then kept going long after its mission was supposed to end. In 2012, it crossed the edge of our solar system's bubble of particles and became the first spacecraft to reach true interstellar space. By November 2023, Voyager 1 had been flying for 46 years. Then, on November 14th, something changed. The spacecraft's science and engineering data collapsed into a single repeating pattern, a signal with no information left inside it. The central mystery was simple to state and terrifying to solve. Something inside a computer nearly a light day away had broken, and nobody could walk over and look at it. The only way to find out what was wrong was to ask the spacecraft itself, and then wait almost 2 full days for an answer. At NASA's Jet Propulsion Laboratory, the Voyager team gathered around old manuals and even older code. Voyager 1 carries 3 onboard computers, each one designed in the 1970s using technology far simpler than a modern calculator. One of these 3, called the Flight Data Subsystem, is the machine responsible for packaging up all of the spacecraft's information before it gets beamed home. Engineers quickly noticed something strange. Voyager 1 was still receiving commands normally, and it was still transmitting a steady carrier signal, so the antenna and the radio were clearly working. The problem had to be inside the Flight Data Subsystem itself, the one computer whose job was to turn raw readings into an understandable message. This was not the spacecraft's first strange episode. Back in 2022, a different onboard system had started sending confused location and orientation data, even though the spacecraft itself was flying just fine. Engineers eventually discovered that system had accidentally been routing its data through a second-long dead computer, which scrambled the information before it could be sent. That earlier glitch had been solved simply by rerouting the data around the broken computer. This new problem, in late 2023, was different and far more serious. The Flight Data Subsystem itself seemed to have lost the ability to speak clearly at all. Every test the team tried came back the same way, a wall of static disguised as data. Commands went up, and only that same broken pattern came down. Suzanne Dodd, the Voyager project manager, later described this as the most serious problem she had faced in her time leading the mission, because a broken translator meant a broken connection with the spacecraft. Communicating with Voyager 1 has never been simple, even when everything works. A radio command takes about 22.5 hours just to reach the spacecraft. The reply takes another 22.5 hours to come back, so every single question the Voyager 1 carries almost a 2-day wait for the answer. That distance turned troubleshooting into an agonizingly slow puzzle. Engineers could not simply try 10 ideas in an afternoon. Each attempt cost nearly 2 full days, so every command had to be planned with extreme care before it was ever sent. Weeks passed, then months, with no breakthrough. The team ruled out possibility after possibility, working through decades-old documentation for hardware that most of its original designers had already retired from or passed away since. Some of the engineers on the modern team had to essentially relearn a programming language that had not been actively used in decades. Then, in March 2024, the team tried something new. They sent a gentle command nicknamed a poke, designed to nudge the Flight Data Subsystem into running its code in a slightly different order. It was not a fix, just an attempt to shake something loose and see what happened. 2 days later, the response arrived, and it was different from anything before. Instead of the same broken pattern, Voyager 1 sent back something new, a complete readout of the Flight Data Subsystem's memory. It was still garbled, but it was a different kind of garbled, and that difference mattered enormously. Engineers compared this fresh memory readout against an old copy taken years earlier, line by line. Buried inside that comparison was the clue they had been searching for. About 3% of the Flight Data Subsystem's memory did not match the old copy at all, as if a small section of the computer's brain had simply gone blank. The cause, they realized, was a single failed memory chip. That one chip had been responsible for storing a small piece of code the flight data subsystem needed in order to function and communicate properly. When the chip died, it did not just lose a bit of data, it erased a working piece of the computer's own instructions. There was no way to repair a physical chip on a machine flying through interstellar space. No astronaut could visit it, and no replacement part could ever be delivered. The team needed another way to bring the flight data subsystem back to life, using nothing but a radio signal and the memory that was still working. Their solution was almost like digital surgery performed from 24 billion kilometers away. Engineers carefully rewrote the lost piece of code, then broke it into smaller sections small enough to tuck into unused corners of the computer's remaining memory. It meant editing decades-old software with almost no room for error, on a system with a total memory smaller than a single modern photograph. On April 18, 2024, the team transmitted the first piece of this patch toward Voyager 1. The command traveled for 22.5 hours through the emptiness between the stars. Then everyone could do nothing but wait, because there was no way to speed up the distance between Earth and the edge of what humans had ever reached. 2 days later, on April 20th, the answer finally came back. For the first time in 5 months, Voyager 1 sent home readable, usable engineering data. The gibberish was gone, replaced by real information about the spacecraft's health, temperature, and systems, exactly as it should be. It was a quiet, almost anticlimactic ending to one of the tensest engineering puzzles in the mission's long history. There was no dramatic countdown or mission control cheering scene broadcast to the world. Just a signal arriving after a 2-day wait, finally making sense of it. Over the following weeks, engineers sent additional commands to relocate the rest of the affected code. Slowly, piece by piece, Voyager 1 regained its ability to send back full science data as well, not just basic engineering status. A spacecraft older than most of the people who fixed it was talking clearly again, from farther away than any human-made object had ever traveled. Why does any of this matter beyond the sheer engineering drama of it? Voyager 1 remains one of humanity's only direct sources of information about interstellar space, the region beyond the sun's protective bubble of particles. Its instruments are still measuring cosmic rays and magnetic fields in a place no other spacecraft has ever reached. Losing Voyager 1 would not just mean losing an old machine. It would mean losing our only working set of eyes and ears in a region of space we may not have another chance to explore for decades. Every extra year the spacecraft survives is more data from a place science still barely understands. The fix itself also reveals something remarkable about long-term engineering. The people who solved this problem were not the same people who built the spacecraft in the 1970s. They had to become fluent in a nearly extinct kind of technology, guided mostly by old documentation, careful reasoning, and an enormous amount of patience. Voyager 1 is not fully out of danger. Its power source, a device that generates electricity from the natural decay of radioactive material, loses a small amount of output every single year. At some point, likely within the next decade, there will not be enough power left to keep any of its instruments running. Engineers have been shutting down non-essential systems one at a time, trying to stretch the spacecraft's working life as long as possible. Each shutdown is permanent, a slow and deliberate sacrifice made to keep the mission alive just a little longer. It is less an ending and more a long, careful goodbye. For now, though, Voyager 1 is speaking clearly again, sending its faint signal back across the growing gulf between it and home. That signal carries real information once more, not the empty gibberish of 5 months earlier. Somewhere out past the edge of the solar wind's protective bubble, a 49-year-old machine keeps calling back to the planet that built it. And that leaves us with a question nobody can fully answer yet. When Voyager 1 finally does go silent for the last time, whether from a broken chip nobody can fix or from a power source that simply runs dry, will it be decades before humanity sends anything else far enough to take its place? Or is that farthest, quietest edge of our reach still waiting for someone to go even further?